Hello. Welcome back to this channel. This is the third and final lecture on the topic of functions and relations. In this lecture, I will talk more about the domain. So, recall that in the previous video, you saw examples of domains that has a finite number of things. For example, we had those 4 cities: Albany, Miami, San Francisco, etc. But domain and range too can have either a finite number of things in it or infinite number of things. So, I will give a few examples how we will see the domain or range have a finite or infinite number of things. So, we have 2 kinds of notations we can use to identify domain and range for many different functions. I will go ahead and write some examples. So, we have 2 different kinds of notation. Set builder notation. It will use the set notation where you use curly brackets. For our first example, x is the first part. This tells you what variable we are working with. It can be x or y. After x, there is a vertical bar. This is to separate 2 things: the variable and the rule for that variable. So, the rule for that variable tells us that x cannot equal 2. It can be any other number. It can be 5,000, or 1 or 0. Now, we can write that in interval notation. It will look like this. So, this tells us starting with negative infinity, x can be any number between negative infinity and 2. Now understand this. There are parentheses. This means it does not include 2. For example, the round bracket after 2. This means the interval does not include 2. It goes from negative infinity to just before 2. Again, 2 is not included. Then we skip 2. Then it can also be any number from 2 to positive infinity. It does not include 2. The symbol U here means n. So, basically, it means we skip 2. So, it can be any number less than 2 and greater than 2, not 2 exactly. I will give another example. So, here's another example of an interval that uses the set builder notation. Again, we are working with x. What is the rule? X must be any number between 0 and 8. It does not include 0 and it does not include 8. It is everything in between. Now, we can write this in interval notation. It will look like this. So, we have round parentheses and in it, we have 0, 8. So, this means x will be between 0 and 8. It will not include the endpoints which are 0 and 8. I will give another example. Now, this tells us we are working with x. The rule for x is that x must be greater or equal to 3. This also means x cannot be less than 3. It must be 3 or greater. So, here's how we will write this in interval notation. So, it will look like this. The square bracket means you include that number. For this example, 3 is included. This is different from above. In the example above, we do not include 0 and 8. So, it includes 3 all the way to positive infinity. The reason why infinity has a round bracket is because infinity has no stopping point. I will give you one more example. Now, we are working with y. The rule for y is that y must be equal to -1 or less than that. So, in other words, y cannot be greater than -1. Now, we will write this in interval notation. It will look like this. Here is what it looks like. Remember that this tells us that y will be equal to -1 or less. So, this means the value of y can go all the way below to -infinity. So, it will start at -infinity and increase all the way to -1. But understand this. -1 is included. So, remember with interval notation, it is important to look at the sign. With this example, we have less than and equal to. This means you use a square bracket. Now, with this example here, we have less than, but no equal symbol. This means you use a round bracket. Now, I will show you a graph and we will need to determine the domain and range. Okay, so, we have this graph. See the U here? It has 2 endpoints. Okay, so what is our job? To identify the domain and range. Starting with the domain, recall that the domain is all of your x values. So, let's look at where the graph starts on the left. At that endpoint, it is at x equals -2. So, notice that the endpoint is closed. This means this endpoint of x equals -2 is included. So, let's go ahead and start writing our interval notation. Remember x is on the x-axis, and to find the domain, always look at the x-axis. Because all of your x values are there. Continue to go to the right. The endpoint is at x equals 2. Again, the endpoint is closed. So, it will be included. It is important when it comes to the domain to look horizontally on the graph. Next is the range. We will look at the y values. We will look up and down the y-axis. Let's start at the bottom and go upwards. So, see here, this is the lowest point, which means y equals -3. It is included because the graph crosses there. So, let's write that. Now, let's go up. Notice that at the endpoints, the graph stops there. Let's look at what the y value is. It is 1. It is included because the endpoints are closed. That's how you find the domain and range, by looking at the graph. Understand that sometimes you may get a graph, and it'll be hard to determine the exact values for the domain and the range. You will need to guess and approximate your answer. But with this graph, it is pretty clear what the domain and range are. Now, suppose we change this graph a bit. We will see how the domain and range will change. Now, what has changed? Before, the graph stopped at those endpoints. Now, it continues upwards forever on the right. It is the same for the left, as it continues upwards forever. Now, the domain and the range will change. Now, let's look at the domain. Remember, you will look at the x values. We look horizontally at the graph. Notice that the graph continues to widen as it goes upwards forever. This means this will be from -infinity to +infinity. This is because the graph widens as you go upwards. Now, next, let's look at the range. Again, the lowest point is still at y equals -3. And it is included. So, let's go ahead and write that. Now, let's go up. Notice that the graph continues upwards. Notice that there are arrows here. This means the graph continues upwards without stopping. So, this means the range is from -3, which is included, to infinity. So, that's how you can identify the domain and range from a graph. Now, we will continue to talk more about the domain. We will look at how to find domain by looking at the function in function notation. Now, I want to remind you something about functions. Now, functions can be continuous. For example, you saw the graph earlier. The function continued in both directions. Or it can be finite, which means it stops at some endpoint or endpoints. It is the same thing with the domain and range. It is important to understand the difference. I will give an example. There's an important difference here. This one tells us we have a set of only 4 numbers. 1, 2, 3 and 4, and that's it. There is nothing between each number. This one tells us it is an interval of all numbers between 1 and 4. It does not include 1 and 4. So, there are so many numbers in that interval. There is 1.2, 1.3, 1.00003, 3.24, and so on. This interval has an infinite amount of numbers between 1 and 4. It does not include 1 and 4. It is important to understand the difference. This one is discrete, which means it has a set of finite numbers. This one here is continuous. This means you have every number possible from 1 to 4. Now, I will give examples of a function and we will need to identify the domain. Here's the first example. So, our function is f of x equals 2 times x. We want to find the domain. One question you have to ask yourself about this function: do we have any restrictions on the values we can substitute x with? For example, can we substitute x with 0? 2 times 0 is 0. If we maybe substitute x with 1000, 2 times 1000 is 2000. Really, you can put any number you want for x. You can put 1/2. 2 times 1/2 equals 1. So, you can put any number you want for x. So, your domain will be it will be from -infinity to +v infinity. This means any number will be acceptable to put in the function. You will always get an output. So, for this specific interval notation, there is another way we can write this. I will show you what it looks like. or that specific interval can be written as r. It is a fancy notation for r. Basically, this fancy r means all real numbers. Both the interval and the r mean the same thing. So, all real numbers can be put in your function here. You always will get an output. I will give another example. You have f of x equals 2 over x. We want to find our domain. Again, ask yourself the same question I gave you earlier. Do we have any restrictions on what we can substitute x with? I want to give one separate example to help you understand the concept of fractions. That example will have restrictions. Let me show you. You have a pizza. Do you like pizza? Go ahead and comment below if you like pizza. So, let's count how many slices we have. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 slices. So, 8 is our maximum number of slices we can eat. So, there will be a fraction. It will look like this. So, if we eat 2 slices, put 2 here. 2 over 8. This means we ate 2 slices out of 8 slices. Or you can reduce the fraction to 1/4. But the point is that the denominator denotes your whole pizza. The numerator denotes what part of the whole pizza you ate. 2 over 8. Now, suppose I write this fraction. Suppose I wrote 2 over 0. That tells us that the bottom denotes that there is no pizza. The numerator tells us we ate 2 slices. This tells us we have no pizza but we were still able to eat 2 slices. Is that possible? You cannot eat 2 slices out of a pizza that does not exist. It is impossible. So, that tells us we have restrictions. So, here, x cannot be 0. This is why we cannot divide by 0. There has to be a number for x in the denominator that is other than 0. For example, x equals 1. This means 2 over 1 which equals 2. If we have 2 over 5, it will definitely be 2 over 5. X cannot be 0, so we can write the domain. X cannot equal 0. I will give you another example. F of x equals the square root of x. Again, ask yourself, does this function have any restrictions on the number we can substitute for x? So, for example, suppose we do something like this. The square root of 2. Use your calculator to compute this. You will see there's an answer. Suppose we do something like this. We have the square root of -2. Go ahead and try that in your calculator. Notice that it may say error, or undefined. This is because you cannot square root of a negative number. If you look at the graph of f of x equals the square root of x, it'll look like this. Notice that there's an arc starting at x equals 0 and continues to positive infinity. The graph does not exist to the left of x equals 0. This means you cannot use negative numbers. Therefore, your domain will be This tells us the value of x inside the square root must be equal to 0 or greater. I will give you more examples using these concepts. Okay, f of x equals x over x minus 3. We want to find the domain. Now, remember that when we discussed fractions recently, remember that the denominator cannot be 0. This means the whole denominator cannot be 0. This applies to this problem. Look at the bottom of the fraction. The top isn't important. The whole denominator cannot equal 0. So, let's go ahead and set up the denominator equal to 0 to see what our restriction will be. We set x minus 3 equal to 0. Go ahead and solve for x. This means we add 3 to both sides. So, this tells us suppose x equals 3 and we replace x with it. In the denominator, it will be 3 minus 3 which equals 0. That number will cause the denominator to become 0. Therefore, that number will be eliminated from our domain. So, our domain will be So, x cannot equal 3. Because remember, if you replace 3 for x in the denominator, 3 minus 3 becomes 0. Which is not allowed. You can put any other number in your denominator. Now, I am going to give the last example. We have f of x equals the square root of x plus 4. We want to find the domain. Now, remember I discussed the square root recently here. Remember I mentioned that the whole thing inside the square root must be equal to 0 or greater. So, again, let's apply this concept to our new problem. Look inside the square root. That is x plus 4. So, let's go ahead and write that. It must be 0 or greater. So, copy that part. Now, go ahead and solve. Subtract 4 from both sides. That is our domain. Now, here's how to visualize this. Suppose -4 for x is replaced in the square root. -4 plus 4 equals 0. Now, the square root of 0 is 0. Now, suppose we use a different number, a number bigger than -4, let's say 0. Substitute 0 for x and we have 0 plus 4. Now, the square root of 4 equals 2. Now, let's try a number that is less than -4. Let's say -5. Now, replace x with that. -5 plus 4 equals -1. Now, you take the square root of -1. Go ahead and use your calculator. You will get an error. So, this means -4 is the lowest number you can put in for x and have a valid output. For the square root to be positive. So, this concludes this lecture on functions and relations. We will continue the topic of algebra in the next video. Thank you for watching me and hope to see you in the next video. Again, thank you for watching. If you have not yet subscribed, please subscribe and click on the bell to be notified when the next video is posted. Thank you. Bye.